another Leetcode problem. 787 cheapest flights within K stops. So we are getting a graph. So this graph is just to simulate the flights. We're gonna calculate the cheapest flights within K stops. So we're gonna use this example to explain it. So for example, we have 3 nodes. This node just means the airport, and there are also the flights. So inside 0 to 1, 0 to 1, it is a directional graph. Yeah, as you can see, 0 to 1, it is 100, and 1 to 2, 100, and 0 to 2, 500. Yeah, and we also have the source and the destination. So we're gonna calculate the shortest path. We're gonna calculate the minimum cost within K stops, K equal to 1. So from 0 to 1 to 2, there's 1 stop, so the cost is 200. We can also go from 0 to 2 directly because it is still within 1 stop. Yeah, it is a 0 stop. But it will cost more because it is 500. But we're gonna return the 200. Yeah. Let me first make a drawing of it and explain what kind of method I'm gonna use it. And then I will go to the code editor to finish the coding. So this problem, I'm gonna use a Bellman-Ford to solve it, because for such problem, Bellman-Ford is really easy to solve. Yeah. So for the yeah, let me make a drawing, and yeah. So for the Bellman-Ford, basically it is a dynamic programming, and for this Bellman-Ford, I'm gonna make a drawing. This is node 0, node 1, and node 2. Node 0 to 1, there is a distance of 100. And 1 to 2, there is a distance of 100. And 0 to 2, there is a distance of 500. Yeah, we're gonna calculate the shortest path within 1 stop. So here, for simplicity, I'm gonna use I'm gonna use a table to explain it. So inside this table, this is I'm gonna use a previous array and current array to represent the Bellman-Ford algorithm. We have 3 nodes. It is 0, 1, and 2. And basically, this is the Bellman-Ford algorithm. For the beginning, we have 3 nodes. It is 0, 1, and 2. We also have 3 edges. It is 0, 1, 1, 2, and 0 to 2. Yeah, this is just the distance. So we're gonna loop through the edges to update this table. But from the beginning, we're gonna have a previous array and current array. So this previous array from the beginning is gonna be the infinite value. All of them will be the infinite value. Yeah. And of course, for the current array, it's gonna always be, be the infinite value. Now, I'm going to loop through the Bellman-Ford algorithm. So for the first one, I'm gonna prepare the first value of the previous array to 0, because from the starting point for this 0 node, I didn't spend any money, so the cost would be 0. So for here, this one, the cost gonna be 0. Yeah, and for others, it will be the infinite and infinite. This is the definition of the previous array. From the beginning, I'm gonna prepare something like this. Now, I'm going to loop through the edges. So from the 0 to 1, there is a distance of 100. Yeah. So 0 to 1, I'm gonna have a distance of 100. This is a 0. I'm gonna use the previous 0. Previous 0, it is a 0, right? And to 1, I have a cost of 100. So 0 plus 100, I'm gonna update the current array. So the current array to 1, it's gonna be 100. So 1 to 2, it's gonna be 100, right? So here, from the 1, the previous array, it is infinite. So infinite plus 100, it is still infinite. So currently, the node 2, it is still infinite. But from 0 to 2, there's a 500. So 500 is less than the infinite. So this value gonna be updated to 500, right? And from the 0 here, for the current array, I'm gonna still give it 0, because the current array is just a copy of the previous array. After copy, this is gonna be 0, and this is gonna be infinite, infinite after updating. So this means I didn't have any stop. Yeah, it is just go like from 1 to 2, 0 to 1, and 0 to 2. It is just finished one while loop. It is just finished one iteration of the array. Yeah, so this is the first iteration. And now I'm gonna go to the second iteration. So the second iteration actually means I have one stop. Yeah. Now for the second iteration, I'm gonna still have the same table. I just make a drawing to put it here. Maybe you can see it clearly. Yeah. So here gonna be not 0, 1, and not 2. Yeah. And inside it's gonna still be the same, the previous and the current array. But for this loop, the previous array will have a copy. We'll have a copy of the current array. So inside here gonna be 0, here gonna be 100, and this one gonna be 500. Now I'm going to loop through the array again because this is the second loop. So the current array for this one, 0, is gonna still be the 0. But for 0 to 1, 0 to 1, it's gonna still be 100 because this is 0 plus 100, it is still 100, the current array. Yeah, as you can see, the current array is also the same. It is from here. Yeah, I'm gonna check the minimum value because 100 with 100, it is still 100. Now I'm going to check from 1 to 2 because for this time I'm gonna use this 100. It's not from here. Here is infinite, but I'm gonna use here because it's the previous value. Actually, it is similar like a rolling array. So this 100 plus 100, it is 200. 200 is smaller than this 500, right? So this value gonna be updated to 200. Now I'm gonna loop through 0 to 2. It is 500. 500 is bigger than 200, so I will not update the value. So currently, I have this current array. And now, my previous array would have a copy of this current array. Finally, I'm just gonna return the previous array with the destination node. It is the last node. It is this 200. Yeah. Maybe it seems a little bit complicated, but inside the coding, it's really easy. Yeah, because while I'm coding, it's also like the copy and paste. I have a previous array. My current array will be a copy of the previous array, and my current array's value will be updated, and then my current array will be given to the previous array, and then I'm gonna calculate again. And finally, because it is one stop, I need 2 loops. After 2 loops, I'm gonna have the final result. The final result is taken from the previous array, so it is this node. Yeah. Now let me go to the code editor to finish the coding. So as I said, I'm gonna use the Bellman-Ford algorithm. I'm gonna prepare the previous array. It is just the number of nodes, and the previous array with a source node. So this source node will be starting from 0. This is similar like Dijkstra's algorithm, Dijkstra's distance array. It's also similar because from the beginning, there's no cost. So it's gonna be 0. Now I'm going to check the flights. I'm going to check how many stops. So if there are k stops, so I'm gonna use a k plus 1. So this means because I'm going to check the edges, if there's one stop, it means I have 2 edges. So k equals to 1, I'm gonna have 2 loops. It means I'm gonna have 2 edges, and I'm gonna calculate the minimum value. Now I'm going to have a copy of the previous array. After that, I'm gonna check the flights. So for UV with the cost in flights, I'm gonna update the current array. So current array, it means it will go to the node v from the node u go to node v because it is a directional graph from u to v. So the current v will be updated. Yeah. So the value will be updated to the minimum of current v with yeah, with what? Yeah, because it is coming from u, so it will be the previous of u plus the current cost. So this is exactly what I explained in the drawing in the, yeah, about the previous array and the current array. First, it have a copy, and then it's gonna update the values inside. Yeah, actually, this is the entire code. We just need to return. Before that, after that, we're gonna yeah, we're gonna prepare the previous array because we're gonna return this previous array, and the previous array is also used for the next loop. If the k is not equal to 1, maybe k is equal to 2 or 3, the previous array would have a copy of this current array. And finally, we just need to return this previous array with the destination if the previous array with the destination is not equal to infinite. Otherwise, it's gonna return a -1. So this is the entire code. As you can see, it's not so difficult. It is basically a dynamic programming, but you need to use a Bellman-Ford to solve it. Bellman-Ford is just to use a previous table and current table. You're gonna update the current table, and then you're gonna give this current table to the previous table to calculate the result. Yeah, actually what I said table is just an array. Yeah, now let me just run it to check. Yeah, as you can see, it works. Now let me submit it. After that, I'm gonna analyze the time complexity. Yeah, as you can see, it works and it's pretty fast. Yeah, so before analyzing the time complexity, let's check the number of nodes. It is n, and the number of edges, it will be n squared. So as we can see here, this is a k. Yeah, because there are k loops, and here is for the flights. So inside the flights, let's check the length of the flights, it would be n squared. So the time complexity would be n squared times k. And let's check the value of k. K is also less than 100. So it means, the time complexity would be 100 times 100 times 100. It is n cubic, so it is 1 million. Thank you for watching.